Hello, everyone. Yeah, good afternoon. Thank you for joining our session. And the session will talk about how to achieve scale to zero and bring the application back up again on Cloud Foundry. And I'm Ying Liu from IBM, and this is Silvestre from SAP. Both of us are working for the Cloud Foundry app-autoscaler project. App-autoscaler project is used to help you to auto-scale your Cloud Foundry application according to the different workload. And this is the project repo and the Slack channel. And just a few weeks ago, we released app-autoscaler 2.0 release to leverage to the latest loggregator APIs and to make it more production ready. And the scale to zero feature is our next most interesting topic that we would like to add into our future release. So today, let's do a preview. This is the agenda. First of all, we will take time to introduce what is scale to zero, how to do it in Cloud Foundry, and our implementation details. And then we will do some brief introduction about the latest update on app-autoscaler for the customer metrics and the UI integration, so that you can understand how the scale to zero feature will be presented on app-autoscaler after it is integrated into the official release. Okay, so what is scale to zero? So when you run an application on Cloud Foundry, you will notice it should be one or more instances. And all these instances running, it will consume some resources, CPU, memory, and so on. And all these resources will take money. Yeah, you will pay for that. If you don't need an application anymore, you can stop it or delete it completely. Or if you are just running a task or job, you can use cf run tasks. And with that command, Cloud Foundry will help you to terminate the application container once the task is finished, so that you don't need to worry about the additional effort, additional cost. But the problematic things is the web application, which don't have a very heavy load. It just has some request occasionally, but you can't stop it. If you stop it, your end user will get error message. So that is where the scale to zero feature can kick in. Yeah. First of all, there is a scale to zero engine to monitor your HTTP request. There are two applications. For my application 2, there are active HTTP requests, so we don't do nothing on that. But for my app 1, there is no incoming request over the defined period. So scale to zero engine will stop that. But after that, it must have a chance to wake up. If there is some new request comes in, the application needs to be wake up. So we add another component. We named it as a router proxy. Once my application 1 is stopped, the router proxy hijacked its routes and pretended it is my app 1 to be ready to accept the incoming request. Once there is an ATP request come to the router proxy for my app1.virtualize.com, it will notify the scale to zero engine to start the original application. And once the application container is ready, yeah, the ATP request will be redirected to it. So you won't get any error message, but you will experience a bit longer latency for the first request. And after that, everything back to normal. The request will be routed to the application container directly. Yeah, so you can see the scale to zero idea is very natural. Yeah, in fact, in the past years, there are several different attempts to achieve scale to zero on Cloud Foundry. The most basic ones is the map the routes to an application, just similar to the command cf map routes. But the problem here is that on Cloud Foundry, the route is a resource related to space. If you have a route in space A, then you can't associate the route to an application that's running in space B. So that requires you must co-locate your route proxy with your target application in the same user space. That is ridiculous. Yeah, you want to scale to zero to save cost, then you need to add another one. So there is another project named AutoSleep. AutoSleep is an open source project as well. It leverages the routing service capability to achieve this. So if you run with the AutoSleep project, you need to create a service instance for that, and then you can use bind the routes to the service instance. I think it's much better, but we still want to provide a more better user experience to make the scale to zero looks like a building experience, looks like a platform extension, so that it's easy to use for you. To achieve that, we revisit the routing architecture of Cloud Foundry. We noticed that in each Diego cell there is route emitter to emit the route information to NAS and then to routing API, and which is served for the GoRouter and TCP router. But here, although in this architecture, the routing API is served for the TCP router, but in fact it has some experimental API to allow us to associate the ATP routes. So that in our current implementation, the route proxy will register the ATP routes to the routing API, and then keep sending the heartbeat to claim the liveness of the routes. And if the application container did wake up, we will unregister it from the routing API. But anyway, it is still experimental API exposed by the routing release. If it can't be GA, it will be not safe enough to introduce it, to do it in the app-autoscaler. So maybe we will fall to the NAS solution, to just broadcast the NAS to register the route to NAS, such as what is did by the route register. Okay, so we have resolved the most important issue about how to hijack the routes. And the other issue and the other problem in implementation detail is how we can get the ATP, how we can monitor the ATP request. So here we need to leverage what we have done in the app-autoscaler. Since in app-autoscaler, we need to scale applications according to its container metrics, CPU memory, or response time, or throughput, or custom metrics. So for us, no ATP request means the throughput equal to 0 over a period of time. So we just need to use that. We leverage the loggregator streaming API to get the container metrics at HTTP start-stop event from the reverse log proxy. So here is the architecture of both autoscaler and scale to 0. All the components in the dash box belongs to us. The orange ones is the public component, which external component is exposed public APIs, and the yellow ones is the internal component. So for scale to 0, the customer, the end user need to define a scale to 0 policy to the API server. It's very easy. It's just enable or disable. And after that, the metric gateway and aggregator will get the ATP start and stop event from the loggregator and do the aggregation. And if there is no ATP request over a period of time, the scaling engine will stop the application, and also the route will be registered through the routing API. The similar workflow will apply to the app-autoscaler as well. The end user can define the scaling policy through the API server by CLI or UI dashboard. And after that, the metrics, CPU memories, throughput response time, and customer metrics will be aggregated, and scaling event could be triggered. Okay, we have talked too much, and it's time to demo. Let me see whether I have luck to do a real demo today. Since just now, just before our session, my Bosch light is crashed. So I just finished the installation over the 40 minutes. So here I have a demo application. I just push. You can see it is running, and now I have. So let me check our push VMs. I'm so sorry. Yeah, since I need to. Okay. Need to our push VMs. And currently, we are delivered the scale to 0 as a separate deployment. Yeah, since we didn't integrate it into the app-autoscaler directly. And to enable the scale to 0 on the demo app, I just need to do this. Let me watch it. Demo app. Yeah, we can watch the status of that. And during the waiting time, we can check what I have done in the script. It's just a CURL request to the API server, and to claim the bridge duration is 30 seconds. So we need to wait for 1 minute. When there is no request, yeah, it will be stopped. Or maybe 30 seconds is too long. We need to wait for a while. Yeah. And normally, sorry, maybe I forgot one thing, to make a request first. Anyway. Hey, come on, come on. So, but anyway, with this script, yeah, I want to, yeah, there is no running instance for this application now, so it is stopped. So let's make a request to this endpoint. To wake it up again. Okay, I make a request, and now it is starting. And yeah, the request is still waiting, as it's still holding. We will hold it until the application container is running. And yeah, now we get the hello world response, and the total latency is 80 seconds. And now we can make a request again. And this time is pretty fast. Okay, so yeah, here, and also we can do a query to check the audit log of what has happened. Yeah, we stop it when there is no ingress request, and wake it up when ingress request received. And to finish that, we can disable that. Okay, as you can see that here, after I push an application, I just need to do some simple API calls. You don't need to band service. You don't need to do anything else. So it is quite easy to consume. We call it as a built-in service. And in fact, you can also consume the same experience in app-autoscaler. Yeah, so that is the part of app-autoscaler, but scale to 0. But just now you can notice we just trigger the scale to 0 with the incoming ATP request. So maybe, but currently we have some custom metrics support in app-autoscaler. So maybe if it is necessary, it depends on the evaluation. Yeah, maybe we can try to trigger the scale to 0 according to your behavior, according to the metrics that you reported, so that it can most up to you to once the application could be scaled to 0. Okay, that's my part. Welcome, Sylvia, to introduce more.
Let's get set up here. So the feature we just saw is, of course, in development and part of the next, one of the next upcoming releases. The feature that I'm talking now is not really scaled to 0. It's I have to switch with one hand. Sorry. But it's a feature that's coming, I think, definitely in the next big release of the app-autoscaler, and that's the custom metrics feature. So what is a custom metric in our case? So we have in the app-autoscaler always had support for the standard metrics, so CPU usage, memory usage, of course response time or throughput, which is basically the inverse of that. And yes, they were always supported, and they come either directly from the runtime in the first two cases, or they are basically derived from just listening to the logs and looking at the HTTP start-stop events, how they were called formerly, I guess. Nowadays they are a little bit different. Custom metrics just allow you, the application, basically to submit metrics to us through a push approach. I mean, that's the current state, and if there are other requests, we could also switch to them, to other approaches, but currently it's a push approach. And of course, that's so that not everybody can just submit metrics for your application. It needs to be, there need to be credentials, and these are the two things that we needed to tackle. So how do you use the custom metrics feature? Basically, you just start by claiming a custom metric in a scaling policy. So this is how a normal scaling policy in app-autoscaler looks like. There's one rule in this scaling policy, and the one special thing is basically that, let's see, let's have a little laser pointer here. Is that we here in the custom, we just define a metric type. In this time it's called custom. That is not one of the standard metrics. So normally there would be CPU or throughput or something like that from the standard metric types there. But in this case, you just write a new string in, and that's the custom metric. And for those that don't know how a scaling rule looks like, it's basically at the moment like that you give it a threshold. You say, okay, if over the threshold with that operator, you need to adjust by +1 by adding one application instance if that rule is triggered. And then you need, of course, that policy to attach your application, either using the CLI with attached policy, or if you are not running the built-in mode, so the app-autoscaler can be provided in two modes, the built-in mode and the service brokered mode, basically. And if you have a service broker, then you can, of course, attach the policy with bind policy, with bind service, sorry. So then you need, of course, a credential to start submitting the credentials to the app-autoscaler, and that's, well, depends on how you set up. If you are using the service broker mode, of course, you get the credential via service binding, pretty standard. If you're using the built-in mode, then you need to either use the command line or the dashboard to create credentials explicitly. And then you start basically submitting those metrics to the metric forwarder component, as it's called in app-autoscaler. It's a very simple payload that you have to give. You have to give the instance index for which this custom metric applies, and then the custom metric itself telling us the value that you want to submit. So in that picture that we saw before, we already saw the components that are now used for that. And that's on the one hand, that metric forwarder that's publicly exposed to your application. There you submit via the REST interface that I just outlined, the custom metrics. The metric forwarder will do exactly what the name says. It will forward the metrics to the loggregator, and then it will flow exactly like the standard metrics flow through the app-autoscaler, and the app-autoscaler will do scaling decisions based on those metrics. Yes, okay, that's basically it for that, and now a small demo for that. That's fine. So let's start from the start. So just one thing that I wanted you to show you. We are now running on EU20, which is a live landscape of SAP Cloud. Oops, That's okay. I completely misunderstand. Sorry. Okay, that's why, because I'm in slideshow. So sorry. So we are running on EO20, which is a live landscape of the SAP Cloud Platform Cloud Foundry environment. With that, I want to show you that even though that feature is not currently in a released version of the app-autoscaler, it's a stable feature already. It's already in GA for SAP customers, so you can already build on that. It's already in use. And one demo that I want to show right now, so when we started offering that feature, of course, we got a request for help, how to use that new feature, and funnily enough, almost all requests outlined one specific scenario in that one that they wanted to use, and that's also a scenario that I want to show you right now. It's basically that they want to have a front-end application or multiple front-end applications, and then they want to submit basically work tasks to a queue, and that they want to have worker nodes that are applications also that pull work from a queue, work on that, and then somehow maybe put the result back into the queue. And that they want, of course, the worker nodes to be scaled based on the current length of the queue, of the depth of the queue, so that it's executed as fast as possible, but not with too many idle worker nodes, let's say. And that's basically the setup that I have now. I've simplified it. I have only one app, of course, and that is bound on the one side on the autoscaler service, on the other side to a queue, RabbitMQ in this, but this is just a detail. And we will start basically by okay, we already see it's only one instance running right at the moment, so we start by submitting some work into that queue, and that is, of course, a very, let's write 1,000 packages into that queue. I think it's a very simple API that I'm offering, so let's see, it's just quick, and let's see what this call actually did. So I wrote it in Node.js. Basically, everything is just setting up the connection to the app-autoscaler. We are in the service brokered mode, so we get the credentials from the app environment, of course, this time, and also the URL that we need to call to when submitting custom credentials. Then we do our setup with the queue. Not very interesting, but here's the most important and also very simple part, that we set up a function that is called, in this case, every 10 seconds. And in that function, we will basically submit the queue length. So we check the queue, and we check how many messages are in that queue, and we'll, from that, construct basically the message that we are sending to the app-autoscaler. There's a unit, if you look closely, that's not in use, basically, and is something that's going away, but in that version it's still there, but it's not used. Of course, we need to get the credentials from also from the app environment. And then we start submitting those custom metrics. So just look quickly if it's doing that. So every 10 seconds, it's already submitting it. At the moment, a value of 970. Let's quickly look at the auto-scaling policy that we have actually bound to that app. I did it through the service binding, but of course you can use the CLI for that. So here's a little bit more in the auto-scaling policy, and we say that if this queue length, this custom metric that we defined, is greater than 100, we do a +2 adjustment. If it's greater than 10 +1, if it's lower or equals than 10, then we start scaling down. Let's look if that actually did something already or not. Let's hope. Nah, of course it's GA software, so it works. We already did one scaling event, so we scaled up by +2 since we were over the threshold of 100, and the rules are evaluated from the top. So in 60 seconds more, 80 seconds more, we will probably scale up a little bit more. So that's basically for that demo. That's the custom metrics feature. And then we go further to the Stratus autoscaler extensions.
In fact, we also, besides the CLI experience, we also have an extension in Stratus to display all the autoscaler stuff in the Stratus. And in the future, once the scale to 0 part came in, it will be displayed in the same flame. Yeah, once you install Stratus and view an application in that, there will be automatic autoscale tab inside. You can check the scale. You can add the scaling policies, schedules, and metrics here. And also for the custom metrics, since you need to generate a credential for that, so there is a menu to ask you to allow you to generate the credential, the API key that you communicate with the metric forwarder. And this is the metrics for the custom metrics, metric display view, and this is the scaling history that just as the same showed by Silvestre on the CLI. So that's what's next for app-autoscaler. Definitely, we will add scale to 0 into the app-autoscaler support, and also another topic is to simplify the scaling rule definition. Just now you can see some long JSONs. So maybe in the future we will change it to a target-oriented approach. The current scaling rule will still work, but will simplify the scaling policy definition experience, and also all the other provide more CLI support to do the implementation. And also, we will do some internal sharding or more HA enhancement to get it ready, and also some document updates. Yeah. Thank you. That's all for us. Yeah.